Okay, so for this problem, we have a simple random walk given by this equation, which basically means we're going one step to the right, say, with 1/2 probability, and one step in the other direction with 1/2 probability. And so if this walk, so you can imagine we're on a number line. We could do straight lines. So imagine you're on the number line, and here's 0. We start off somewhere at k, and the question asks what is the probability that we would hit L, which is somewhere to the right of k, so maybe this is L, before hitting 0. Okay, so in general, the quick answer is that when you're asked what's the probability you hit this spot before this spot, well, it's this distance divided by the total distance. So in other words, the answer is k over L. And that's the quick way to do it. But of course, if anyone actually asks you this, you should be able to explain your answer. And so we're going to try to derive how you get this. And so the way you do that is kind of this recursive formula where you're going to express each state in terms of other states. And so what do I mean by that? So let Pn be the probability you hit L before 0 from position n. Okay, and so now that we've sort of expressed our problem in terms of this, then we note that the original problem asks for pk, this probability that you hit L before 0 starting from position k. And then there are what I like to call base cases. So P0, the probability you hit L before 0 if you start in position 0 is 0 because you've already lost. On the other hand, PL is 1. Okay, because if you're already at L, then you've already won. And so then you need a recursive relationship. So if you're familiar with like dynamic programming, you might recognize this kind of setup where we try to express our problem in these sort of subproblems, and then we identify a base case and some recursive relationship between the subproblems. And so in this case, the recursive relationship is, well, if you're at position Pn, then, well, what can happen? With 1/2 probability, you move to the right, and so now the chance you hit L before 0 is Pn plus 1. And with 1/2 probability, you move to the left, and now the chance you hit it is Pn minus 1. Right, and that's pretty simple. I mean, looking back up here, at each point you either go here and now your probability is pk plus 1, or you go here and now your probability is pk minus 1. So let's see what this recursive relationship tells us. Well, if we multiply by 2, then we get this thing. And now we can, so the idea is our sort of ordering is either to increase n, or decrease n. And usually you have a 50% shot of which one works first. And so you can do n plus 1. We could try that, which is 2pn minus pn minus 1. Okay, and so the idea is we're going to use one of our base cases and see which one works better. So 0 is certainly a nicer number than 1, so let's see what happens if we try that. And so we have let's do p1 plus 1 equals 2p1 minus p1 minus 1. So that's the n equals 1 case, which means p2 is 2p1 minus p0, which is 2p1. And so basically we're going to keep going to see if we can find some kind of pattern. So p3 equals 2p2 minus p1, but we can use the fact that p2 is 2p1. So this is 2 times 2p1 minus p1, which is equal to 3p1. All right, and then we could keep going. Or do we need to keep going? Let's do one more, see if we can pick up the pattern. P4 is 2p3 minus p2, but p3 is 3p1 and p2 is 2p1, so let's plug those in. 2 times 3p1 minus 2p1, which is 4p1. So at this point we conjecture, maybe a little strong of a word, but we guess that Pn is equal to n times P1. And it's not so hard to prove this with induction. You can also prove it directly. Okay, but once you know that, then what can you do? Well, the only other thing we haven't used is that PL equals 1. So let's just try to figure that out, or rather use that information. So if this is true, that means PL is L times P1, but we know that PL is 1. So this implies that P1 is 1 over L. And now we're basically done, because then the question asks for what is PK. Well, PK is KP1 by our conjecture here. And so that means that PK is K times 1 over L, or K over L, as claimed. So maybe as an exercise at home, you can try to prove this statement by induction and probably using this recursive relationship here. But yeah, that's a quick and easy way to figure out these sort of random walk questions. Let me know what you guys would like to see next.